Nothing, Father. I have a question.
Yeah, tell me.
What is the growth rate of population in our country?
Good question. We can find the growth rate by using derivatives.
How can we use derivatives to find out growth rate?
Would you like to learn more of it?
Yeah, Father.
In this lesson, you will learn the applications of derivatives. Objectives. At the end of this lesson, you'll be able to find the rate of change of quantities, analyze the increasing and decreasing intervals of functions, find the equation of tangents on a curve, find the equation of normal on a curve, approximate the roots using differentials, find the maximum and minimum value of a function, find the maximum and minimum value of a function in a closed interval. Rate of change of quantities. The derivative is defined in a way that it gives the instantaneous rate of change of a function. The standard example of this is that f of t gives the position of an object at time t. F dash of t gives the velocity of the object at time t. Let's take some examples of quantities that change with time. If f of t is equal to population of bacteria, f dash of t is equal to growth rate of population. If f of t is equal to amount of radioactive material, f dash of t is equal to rate of decay. Example: the side of a square sheet of metal is increasing at the rate of 3 cm per minute. At what rate is the area of the sheet increasing when its side is 10 cm long? Solution: let x be the side and a be the area of the sheet at time t. It is given that dx by dt is equal to 3 cm per minute, name it as 1, and a is equal to x square, name it as 2. Differentiate equation 2 with respect to t. We get dA by dt equals 2x into dx by dt. From equation 1, dA by dt is equal to 6x. Now the rate of change of area when x is equal to 10 cm is dA by dt at x is equal to 10, which equals 6 into 10 square centimeter per minute, equals 60 square centimeter per minute. Assessment. Before proceeding further, let us know how much have you learned. Fill in the blanks. Increasing and decreasing functions. A function f is increasing on an open interval I if for any two numbers x1 and x2 in the interval, x1 is less than x2 implies f of x1 is less than or equal to f of x2. A function f is decreasing on an open interval I if for any two numbers x1 and x2 in the interval, x1 is less than x2 implies f of x1 is greater than or equal to f of x2. A function f is strictly increasing on an open interval I if for every x1, x2 belongs to I with x1 less than x2, we have f of x1 is less than f of x2. That means f of x gets larger as x gets larger. A function f is strictly decreasing on an open interval I if for every x1, x2 belongs to I with x1 less than x2, we have f of x1 is greater than f of x2. That means f of x gets smaller as x gets larger. There are functions which are neither increasing nor decreasing. Let's have an example. The given below function is y, which equals cos x. Theorem. Let f be continuous on a closed interval a, b and differentiable on the open interval a, b. Then, f is increasing in closed interval a, b if f dash x greater than 0 for which x belongs to open interval a, b. F is decreasing in closed interval a, b if f dash of x less than 0 for each x belongs to open interval a, b. F is a constant function in closed interval a, b if f dash of x is equal to 0 for each x belongs to open interval a, b.